All right, number 22, solve the system by elimination, and we've been given two equations in this system. The first equation, x plus 7y equals 9, and our second equation, 5x plus 6y equals 16. And with elimination, what we have to decide, first and foremost, is do we want to eliminate the x variable or do we want to eliminate the y variable? It doesn't matter which variable you decide to eliminate first, we will still get the same solution at the end regardless of which variable we start with. Generally speaking, you want to choose the variable that's easiest to eliminate. And in this case, looking at this system, it will be easier to eliminate the x variable versus the y variable. So remember, in order to eliminate a variable, and in this case we're going to eliminate x, we want the coefficient of the x terms in both of these equations to be additive inverses. That means if this x here has a coefficient of positive 5, we need the x in this equation to have a negative 5, because a negative 5 plus positive 5 will cancel each other out, will eliminate each other. Well, right now the x in the first equation has a coefficient of 1. So what do we need to multiply 1 by to get it to be a negative 5? Well, 1 times negative 5 is negative 5. But remember, we can't just randomly multiply a single term in an equation. If we're going to get this 1 to be a negative 5, we've got to multiply the entire equation by negative 5. So that's what we're going to do. We'll multiply the first equation by negative 5. And so negative 5 times x is negative 5x. Negative 5 times positive 7y is negative 35y. And lastly, negative 5 times positive 9 is negative 45. And so I'm going to go ahead and actually rewrite this system with our multiplication. So we had 5x plus 6y equals 16, and then negative 5x minus 35y equals negative 45. All right, and now all we're going to do is add vertically. 5x minus 5x goes away. 6y minus 35y gives us negative 29y. And then positive 16 minus 45 gives us negative 29. And if we're solving for y, we're going to divide by negative 29 on both sides. And so we're left with y equals negative 29 divided by negative 29 is a positive 1. So we've just solved for y. Now what we have to do is take this y value and plug it into really any of these three equations and solve for x. I'm going to take this y value and plug it into the first equation for y. All right, so if we plug that y value in, we'll end with x plus 7 times 1. We just found what y was, so we're replacing y with the y value that we just solved for, equals 9. Well, we'll distribute here, so we end with x plus 7 equals 9. And if we want to get x all by itself, we'll subtract 7 from both sides, and that leaves us with x equals positive 2. So now we've solved for x, we've solved for y, so we have to write our solution as an ordered pair. So x comma y, or in this case 2 comma 1. This is what we're claiming is the solution to the system. But it's a really good idea to get into the habit of checking your solution. All right, so I'm going to get rid of all this work here, and we'll actually check to verify that 2 comma 1 is in fact the solution to this system. And to do that, what we're going to do is take this ordered pair, right? This member is your x and your y, and we're going to plug this solution into each equation of the system to verify that we get a true statement. All right, so let's plug it into the top equation and see what happens. So we have x plus 7y equals 9, or if we're plugging in our solution, x, which is now 2, plus 7y, but y is 1, equals 9. Well, here there's no sign outside the set of parentheses that's going to change the sign of that 2, so those parentheses can go away. Here, positive 7 when we distribute it is just a plus 7 equals 9. We know 2 plus 7 is 9, so 9 equals 9. That is a true statement, and so we know the solution 2 comma 1 works in equation 1. All right, let's try and see what happens when we check it for equation 2. So we have 5 times x, but x is 2, plus 6 times y, but y is 1, equals 16. We'll distribute. 5 times 2 is 10, plus 6 times 1 is 6, equals 16. 10 and 6, we know when we add them together, we get 16. So we have 16 equals 16. So it works in the second equation as well. If the solution that you find only works in one of the two equations, it is not a solution to the system. If the solution you find doesn't work in either, or rather if it doesn't work in both of them, it's also not a solution. The solution, the ordered pair that you find, has to work in both in order to be a solution to the system. So definitely on a test, I recommend whatever you find to be your solution, take the 30 seconds or 60 seconds, take that solution, plug it back in to verify that it works in both of the equations, or if we had 3 equations, you're going to plug it back into all 3. It's a surefire way to make sure that the algebra you did finding this ordered pair is in fact correct, and so that you know with confidence that if it works in both equations of the system, you definitely got this one correct. All right, that was number 22. Let's take a look at number 23.